Hi, so in this video, we're going to talk about natural logarithms. Natural logarithms, and they're just log with the base e. And e is the special number known as Euler's number. And e is equal to 2.718. And it's an irrational number. So it goes on and on. It's non-terminating, non-repeating. It's an irrational number. So natural logarithms is basically, so if you look at here, you have the graph of e to the power x. And basically, it's very similar to the graph of a to the power x that we were talking about. And because e is greater than 1, e is 2.718, then it looks like this. It's not the other way around, as it would have been if e was less than 1, but it's not. And then its inverse graph, when we flip it over the line y is equal to x, we get its inverse graph. And this is ln. Ln is the natural logarithm. So in your calculator, you will also see the ln button, and that is the natural logarithm, which means the logarithm with the base e. And that is all you need to know, and we can directly start going to the questions because we've already learned how to work with logarithms. This is just using a different base, and sometimes it's easier to use base 10 or base e. Those are the standard bases we work with, so it's easier to work in terms of base e and base 10. So using a calculator, just evaluate. So this is very standard, very easy. You can just put it in your calculator. E to the power 3 is 20.1 to 3 significant figures. And e to the power 2. Or the last one, 0.8, would be 2.26 to 3 significant figures. 2.23 to 3 significant figures. So these are like questions that you can solve. Just put in your calculator and figure out. So that's very easy. And this is very easy as well. You just take your calculator and you press your ln button. And when you say ln, the calculator is programmed to know that it's the natural logarithm. So the base is going to be e. And ln of 3 is 1.10. Or say ln of 0.9 is going to be negative. It's going to be negative 0.105. Something like that. Negative 0.105. So that is how you do these questions. Now, without using a calculator, find the value of. And this is the same question. This is the same. So if I had 10 to the power log base 10 of 2, then you know that this is 2. And we have been doing this type of question. If you have 10, then you know that this is immediately going to be 2, right? This is something that we have been working on in the previous video. And it's the same situation here. This is going to be 2 because the base of our natural logarithm is e. So you can directly get this answer. And we have looked at the reason why. If you have a to the power log base a of b, the answer is going to be b. Because if I say that log base ab is equal to p, a to the power p gives me b. And this is just p. So my answer has to be b, right? So this is going to be equal to 2. And this is going to be equal to 3. The power rule tells me that I can take this half as the exponent of 9. 9 to the power half is 3 because it's the square root of 9. So this gives me 3, I believe. So I'm simultaneously checking the answers so that I don't say something wrong. And this is going to be 5 times 6, right? Because this part just simplifies to 6. So this is 30. And this one, see, 1 over 2 is just 2 to the power negative 1. And you can bring this negative 1 to the front. So essentially, the negative 1 and this minus sign at the front, they simply cancel out and you get 2. So solve. And this is just x is equal to 5. This is something that we have been doing for so long, so I'm not going to spend a lot of time. And this is x is equal to 15. Why? Well, we already said log base a to the power x is going to give us x, and we can actually take this x to the front. And log base e of e is just 1. So x is 15. So log base a of a to the power x is equal to x, and a log base ax is also x. These also follow from the properties of inverse functions. So this one tells us that, so 515, this one tells us that x cubed is equal to 64, and therefore x is equal to 4. And this one tells us that 1 over x is equal to 3, and therefore x is equal to 1 over 3, right? Because this, again, the negative sign, we can just put it as the power of x. So I get x to the power negative 1 is equal to 3, which means 1 over x is equal to 3. That means x is equal to 1 over 3. Question 5 says solve giving your answers correct to 3 significant figures. So I will not do all of them. So basically, you just want to take the natural logarithm here of both sides. And when you take the natural logarithm, you get ln 18. Natural log, because this just simplifies to x, and you get ln 18. And ln 18 to 3 significant figures is 2.89. And let's do part C. This just tells me that e to the power x times e to the power 1 is equal to 8. Right? This gives me e to the power x plus 1. So e to the power x is equal to 8 over e, and I can take log both sides. So natural log of both sides is just 8 over e. X is equal to natural log 8 over e. And that is 1.08. And the part D is, you would solve part D in exactly the same way. See, e to the power 2x minus 3, well, that is e to the power negative 3. Or, well, you could write it as e to the power x over e to the power 3 is equal to 16. So e to the power 2x is equal to 16 e to the power 3. And it's equal to e to the power 3. And e to the power, this is actually e to the power x squared is equal to 16e cubed. So you can take the half power on both sides to get e to the power x. And finally, you can take the natural log. So that gives x is equal to natural log. So it's natural log of 16 times e cubed to the half power. And that gives me 2.89. So this simplifies to 2.89 to 3 significant figures. I know I solved it a bit quickly, but I think we have done enough questions that our intuition has built up so that we are able to, and I think the algebraic simplification is simple enough that you can figure out what's going on here. So question 6. Solve giving your answers in terms of natural logarithms. So we just want to leave it at the log. So like I said, this is just going to be, if I take natural log of both sides, then I get x is equal to ln 13. And if I take, again, the natural log of both sides, I get 3x is going to be equal to ln 7. So x is equal to 1 over 3 ln 7. And here, if I could directly take the natural log as well. And if I directly take the natural log, I get 2x minus 1 is equal to ln 6. Because the exponent comes to the front and ln e is just 1. So 2x is going to be ln 6 plus 1, and x is going to be half ln 6 plus 1. And for part D, you can just bring your exponent to the front after ln e is equal to ln 4. So I'm doing this very quickly because what we did was we just took the natural log of both sides. And these are like the same type of questions that we were doing with base 10. So I'm hoping that the intuition has developed enough, or my explanations have been clear enough so that you can follow what I'm doing. So ln e is just going to be 1, and half x is equal to ln 4 minus 3. So x is equal to 2 ln 4 minus 3 to the 6. Or 2 times ln 4 minus 3. So that is how you do question 6. These are the same types of questions that we have been doing with. So this is logarithmic inequality, exponential inequalities, just with base e. So we can take natural log of both sides again. And that gives us x is bigger than ln 10. The ln function, the natural logarithmic function, is also an increasing function. So basically, if e to the power x is bigger than 10, then ln e to the power x has to be bigger than ln 10. So therefore, x is bigger than 10. And if for b, we can say that, hey, if I take the natural log of both sides, I get 5x minus 2, or let me just do it. E to the power 5x minus 2 is less than or equal to ln 35. So therefore, 5x minus 2 times ln e is less than or equal to ln 35. And ln e is just 1. So 5x minus 2 is less than or equal to ln 35. And therefore, when you simplify this, I believe you should get x is less than or equal to ln 35 plus 2 divided by 5. Or 1 over 5 ln 35 plus 2 is the same answer. For part C, we have 5 times x. So we can divide by 5 on both sides. That is perfectly allowed. And we don't have to change our inequality because 5 is positive. So e to the power 2x plus 3 is less than 1 over 5. And when I take the natural log of both sides, I get 2x plus 3 is less than ln 1 over 5. Or we can write this as negative ln 5, right? Because ln 1 over 5, well, you can rewrite 1 over 5 as 5 to the power negative 1. And you can bring the negative 1 to the front. That gives me minus ln 5. So 2x is going to be less than ln 5 minus 3, and then x is going to be this value. So minus 1 over 2, 3 plus ln 5. So this matches the one in the textbook. So this, if you think of it, is just negative half ln 5 plus 3. It's the same answer. Solve giving your answer correct to 3 significant figures. Well, if I see e to the something, then I know I have to take the natural log. So if I see the natural log, then I just exponentiate it. So I just put it in the exponent. And therefore, I know that this side just collapses to x. We get e to the power 5. And e to the power 5 is 148 to 3 significant figures. And this is the same thing. This is just e to the power negative 4 is x. And e to the power negative 4 to 3 significant figures is 0.0183. And again, e to the power 6 is just going to be x minus 2. And I highly encourage you, I'm skipping some steps so that you can just fill the gaps in. But I believe we have done these types of questions enough for you to sort of know that if I take e to both sides, then this is just going to be x minus 2. And on the right-hand side, I'm going to have e to the power 6. So e to the power 6 plus 2 is equal to x, which is to 3 significant figures plus 2 is 405. And I leave the last one because it's essentially the same thing. So solve giving your answers correct to 3 significant figures. And let me just take this to the other page so that we can sort of avoid crowding ourselves. So let me just do this very quickly. So if I paste it here, all right, so we have space down to complete these. So the first is ln 3 minus x squared is equal to 2 ln x. And from this side, we know x has to be greater than 0. The same idea that we were talking about. If you look at the graph, x is always greater than 0 for any log function. So x has to be bigger than 0, and 3 minus x squared has to be bigger than 0. And that means that if I subtract 3 on both sides, then I get minus x squared is bigger than minus 3. Right? I subtract 3 on both sides. And I know that when I divide through by -1, I have to flip the inequality. So x squared is less than 3. And that means that x is less than 3. X has to be less than square root of 3, but it has to be greater than the negative square root of 3. And I think you can sort of figure this out. Because if a negative value squared can also be less than 3, remember? So if my value is negative, but it's bigger than negative square root of 3, meaning that it's closer to 0, then when I square it, then it's still going to be less than 3. So if it's exactly negative square root of 3, then it's going to be 3. I don't want it to be equal to 3. If it's something lesser, maybe it's negative square root of 4. When I square it, I'm going to get 4. And I want x squared is going to be 4, which is not less than 3. So this is going to be my bound. And generally, if I say, hey, x squared is less than a, that means that x is less than square root of a and bigger than negative square root of a. So this is something useful to remember. So we have two conditions. However, well, because I already said that x is bigger than 0, it cannot be between -3 and 0 here. So it has to be 0 and it has to be less than square root of 3. So that is something to remember before we start solving. So now I can just say, hey, 3 minus x squared ln is equal to ln x squared. And therefore 3 minus x squared is equal to x squared. 2x squared is going to be 3. X squared is going to be 3 by 2. And x is going to be positive because it cannot be negative. It's going to be positive root 3 by root 2. And root 3 by root 2 is definitely less than square root of 3. So to three significant figures, 3 by 2 to the power 0.5 is 1.22. So that is the only answer.